Today, we are going to discuss about the topic that is the structural features what we can see on the surf fault. We hope by the end of the session you will be able to understand what is a fault and how it can be identified in the field and how a civil engineer can utilize this information for designing the structure or deciding the structural characteristics of the construction. So, if you remember that we studied about the rocks, we discussed that the rocks are forming on the surface. So, the rocks which are forming on the surface are undergoing number of different processes of deformation. Deformation, what I mean here, it is any kind of change in the rock due to forces applying on that. These deformations which are going on the rock may be an elastic deformation, or it may be a brittle deformation, or it may be a ductile deformation. So these deformations which going on or applying on this rock will produce the rock into a different structure, or a different structures will be produced in the rock by the application of these different kind of forces. So what are these forces? The force may be a confining pressure. What will happen? The size of the rock will reduce, and if it is a compressional force, then it will be the shortening of the rock structure will happen. And if it is a tensional forces, then it will stretch the rock. And if it is a shear force, then it will be a sliding or a shearing or tearing which will happen into the rock. So you should understand that whatever we are showing here on the picture, this is just an example, but the processes which are happening on the earth surface would be, or maybe a combination of all these different processes at the same time. So as a result, when these processes are acting on the rock may get deformed into different structures, and these structures are depending on that what kind of deformations, depending on the forces applying on that, and based on the deformations, the structures which are going to produce on the rock can be divided into two categories. The first is called a faulting, that actually breaks the rock when the rocks are undergoing the pressure or undergoing different forces. So if the rocks are undergoing in the forces which are on a shallow depth, that means there is no confined pressure from the top, and the rock is able to move. The pressure which is applying from the bottom and top is less, whereas the pressure which is applying from the sides are more. So that is what I am saying, that it is in a shallower depth because there is no load from the top. So in that situation, what happens, the rock may break and the faulting may happen, and that structure which is produced by the process is called a fault. So there are different type of fault depending upon the forces applying on that. If it is a compression force, then the rock may fault something like a reverse fault. We study what is the reverse fault. And if it is a tension means the forces are applying away from the rock, so it is causing the lengthening of the rock. But when lengthening of the rock means it is cutting, it is going to break the rock, and the break will be seen in the structure or something like a displacement on the fracture. So that will be called as a fault. So shearing will happen when it is a strike. We'll study this. We'll study in detail that what are the different terminologies. But at the time being, there are two type of deformations we are going to study here. One, it is in the shallower depth when it is applying the forces on the rock. Depending upon the forces, the rock may fault, and a different kind of faults can be produced. These are different varieties of faults. Okay, so the second thing is that when the rock is under greater depth, okay, it is deeper in the surface, so the forces when it is applying on the rock, it is also having a confined pressure. The top and bottom will also have a pressure because it is a greater depth, and it is not allowing the rocks to break. Rather, it will allow the rock to deform in a ductile manner. Okay, so these ductile deformations will produce a feature that is, we call it as the wavy undulations on the rock. So these wavy undulations means the rocks gets folded. So we use that terminology, or we use that structure which is produced by this kind of deformation on the rock is called a folding. So this is different varieties of faults. Either it is a compression, tension, or shear forces. Different kinds of faults can be produced on the rock. So this is what basically the deformations, the basic deformations which the rocks are undergoing. We are going to discuss these things one by one. And the first one we are going to discuss is a fold. What is a fold? Fold is a wavy undulations seen in the rock. Okay, so when you are talking about a fold, as we know that it is a folding or is a wavy undulations which are seen on the parts. And when I'm saying that it is a wavy undulation, so there are different parts on the fold. So we are going to discuss briefly that what are these different parts on the fold. First one we call it is a limb. So seeing here, these are two limbs of the fold. Okay, so these are the terminologies what you are talking about. The limb is what? It is the flanks of the fold or the sides of the fold. Okay, so when there is a rock layer which applies force, and now this is converting into a fold. Okay, so one part of the fold, this is called one limb. Another part of the fold, it will called another limb. Okay, so this is one fold and two limbs. So this may have number of series of foldings in the later. Okay, so if you see this fold further, this is another fold. This will have one limb here. Okay, this will have another limb here. So this is a downward folding and this is an upward folding. So this way the successive folding may continue, but what we are referring to right now here is the flanks of one particular fold. Okay, we are not going into the details of that, and that limbs are having either a crust or a trough. So it will have a crust portion and then it will have a trough portion. So it is basically a successive crust and trough portions. Successive crust and trough. Okay, so this is one crust, this is one trough, then this is another crust, then there will be another trough. So line running through the highest point on in an up arched fold is crust, and the down arched part is the trough. So now there is the next thing, that it is the hinge. Hinge is the junction of two limbs. So this is one limb and this is another limb. Okay, this is flowing on the crust. So where there would be, if I find out the dip of each of these points, then all these points will have one point on the top of this limb which will have a maximum inclination. And if I join that lines together, so that we call it as a hinge of the fold, and the line which connecting the hinge we call it as a hinge line. So these are the basic three parts of a fold. Now the next part of the fold is an axial plane. So axial plane is an imaginary, we cannot properly put it, is an imaginary plane which is dividing the fold into two equal halves. So it may coincide or may not coincide with the fold axis or the fold hinge lines, but it is an imaginary plane which is passing through the point of maximum curvature in the fold or in the hinge lines. So it may be a straight line, it may not be a straight line, it may be a folded or it may be an inclined. So number of different varieties of axial planes can be seen, and the axis of the fold is the hinge line parallel to the hinge line at the top of the fold. So these are all the axis of the fold. So hinge line and the axis of the fold are sometimes it is going to be coinciding and it will be a same points. Then we have one more thing which is a plunge. Okay, plunge is nothing but, for example, if I consider a fold, this is a fold and this is the three-dimensionally, if I see this is the fold. So this fold here, the angle where the fold, if you see, this is 0 degree. So there is no inclination of this fold axis. But when I see another fold and which is having a dip which produced with the horizontal, or what is it making? The axis of the fold is having an inclination amount any angle theta. So this angle is called a plunge. So this angle is called a plunge. So every time whenever we see a fold, so fold axis, if it is horizontal, we call it as a non-plunging fold, and if the fold axis it is inclined, we call it as a plunging fold. I'm actually summarizing all the parts. So this is an axis of the fold axis, hinge area, then it is a limb, then it is a crust, trough, and this is a crust portion, and you can see that this portion is common for both. for the anticline and the syncline. Okay, I used two terminologies here. One is anticline and another is syncline. So what is this anticline and syncline is the basic classification of a fold. If the fold is C and the folding is convex upward, folding is convex upward, where the limbs are dipping away from each other and the older rocks seen in the center and the younger rocks seen in the outer layer. This is younger, this is older. So this is called an anticline folding. This is called an anticline folding, and the inverse of that, where what happens, the younger rocks are seen in the center of the fold, the folding is dipping towards each other. If you remember the dip what we discussed yesterday, dipping towards each other, and the convex downward folding is called a syncline. So anticline and syncline is the basic terminology what we use for a fold to be classified. So this means when I am going on the surface, if I'm going to do some construction on the surface, what I see here, it is the youngest rocks and the rocks are dipping towards each other. But where here the rocks are dipping away from each other, so that is a anticline, and this can be easily remembered because when we say anticline, the first word is A. So A means the rock is which is folding upward or the convex upward. Okay, and the syncline is the opposite of that. And the layer of rock, when it deposits, always the oldest rock will be at the bottom, then it will be younger, then it will be youngest. So at the top we will get the youngest in the anticline, and the syncline will get it in the center of the syncline. So anticline and syncline are the rocks or the basic classification of the fault based on its shape, or based on its process, or based on its geometry of the fault. So there are number of other classification. And one more example, if in sometimes we may not be able to identify that whether the oldest rock is at the center or the youngest rock is at the center, or the age of that rock may not be able to establish. In that situation, we call it as a syn forms or antiforms. And there are a number of other classification schemes for the fault. We classify the fault based on the axial plane. So there are symmetrical fault, the limbs of the symmetrical fault tip in opposite direction at the above same angle. So both the limbs are dipping towards each other at same. So here it is an asymmetrical fault. Here it is an overturned fault. Both limbs are overturned and dipping almost in the same direction. So these are three kind of faults. So these are all the details of the classifications of the fault. And if you see, these classifications are based on number of different parameters. Okay, based on the position of the axial plane, that is what just we have seen on the previous slide. Then it is based on the degree of compression. So sometimes the rock may be open, sometimes the rock may be closed, sometimes it may be gentle, or behavior with depth, that how the changes in the rock varies when we are going down to the layers. So relative curvature of outer and inner, plunge of the fold, plunging fold and non-plunging fold, the box fold, as in chevron fold kind of things, when it is based on the profile and where it is occurring. And there are a number of other folds we classify into the miscellaneous type of folds, which are basically they are not coming under any of this specific criteria. So there are a number of classification schemes and terminologies we will find in the textbooks or even in the reports. So you can just browse through that. What are these different classifications, and which doesn't come in our purview at this point of time, where we are just having an idea about folding and how the fold are identified and what are position users as a civil engineer will have. In just for an example, I can tell you some minor folds, where it is a buckling fold, where it is a bending kind of fold, where it is an isoclinal fold, where it is an overturned fold, where it's an recumbent fold. So these are all different varieties of fold. Ultimately, what are these? These are all folds, but the classification and nomenclature is based on different parameters. Here, if you see the rock, here see that the axis of the fold is almost horizontal. So this we call it as a recumbent fold. Okay, isoclinal fold, the folds are dipping on the same direction or in the same angle, which is dipping. Okay, so that kind of different varieties of folds and things can be found in the literature. So I suggest that you people be little go more and find out this different varieties of faults from the textbook or from the reports and have a general idea. Otherwise, it doesn't come under our purview at this point of time. So I'm leaving that the classification scheme of faultings here and going to the topic. What is important for a civil engineer is identification of a fault. So how do we identify that whether the area is having a fault or not? If while preparing a geological map, what do we mean by the geological map? Geological map is actually a map which describes the geological characteristics of the area. So this geological maps here, what we are seeing, which is having a rock, when the pink color what you are seeing is a central crystalline area. So where there is one kind of rock, there is another kind of rock, then there is a repetition of rock, and this rock and the light yellow color. So there are rock types 1, this both are same. This is rock type 2, this is same. There is a rock type 3 and there is a rock type 4. There are 4 different rock types are seen. And when as geologist I make a cross sectional view. Cross sectional view means I am imagining that I cut the rock, the area in this layer, and I imagine that how the rocks are seen. This is how the rocks are something I'm going to see. Here I will see the rock type 1. Okay. And here also I will see the rock type 1. And here I will see the rock type 2. This rock type 2. And here also I will see the rock type 2. Then I will see the rock type 3. Here also I will see the rock type 3. And the center, this rock types 4, I will see. So now what it is indicating, this is indicating that the area is having what structure? The area is having a folded structure. It was some time before was something like this, and the rocks of the surface got eroded and now this forms. So this kind of map, so this we call it as a geological map. So interpretation of the geological map will help us to identify the area. So this is one method. Second method is the measuring the attitude of the strata. Okay, measuring the attitude of the strata means this is what I was just talking about, that the example we discussed in the yesterday's lecture also, where one area that fellow find out the dip of the rock. So now the rock is dipping towards this direction. He found the same rock type here and he find out the dip of that strata, then it is dipping towards this direction. So what does it indicate? The rocks below is having a folded strata. Similarly, here the rock is dipping towards this direction. Here the rock is dipping towards this direction. So this line actually indicates the strike and dip. The longer line indicates the strike direction and the shorter line indicates the dip direction. So here this symbol represents a which kind of fault? This is an anticlinal fault. And the symbol, if you find this way, that means strike is parallel but dipping towards each other, that indicates a synclinal fault. So when we find out the attitude of the beds from different areas on a geological area, so these attitudes, when we plot it on a map, the map will tell me that whether the area is having a dipping strata, uniformly dipping strata, or a folded strata. So these attitudes will help me to identify the fault. And the third method, it is the drilling techniques. So here, which is actually doing a drilling process. When I make a one drill, I get the rocks at, for example, at a depth of 30 meters. When I drill the same rock with the same rock, I get at 60 meters. When I make the third borewell, I get the rock at 90 meters. And here when I drill, I will get the rock again at 60 meters. So this indicates the rock, one layer which is below is dipping. So this will show me that the folded strata. But it is a very costly process. For example, like this area is what it is shown in the upper figure. Okay, so you need to drill all this area for identifying just a folding. So that is not a correct way, because drilling is very costly affair. Okay. So here we see all these areas where the drillings are done. And this is basically done for the petroleum process. So that is different thing. But for a construction purpose, if a civil engineer needs to drill hundreds of borewells to identify a structure below, then it is not an economical aspect, as we only spend around 10% of our total project cost for the geotechnical engineering process. So all these things, the geological studies and designing understanding the soil bearing capacity, doing basic test, everything comes under. And if you are going to increase the spend on geotechnical engineering, that will obviously improve the quality of the building, but it will increase the cost of the building. So that is not economical. So a basic geological information will be able to do, and some testings may be done by drilling process to identify whether these interpretations what are made based on the geological mapping or the surface attitude bed measuring is correct or not. And if that doesn't work, there are a number of geophysical methods are available to see. And these geophysical methods, we call it as an electrical method, seismic method, and gravity method. So electrical seismic is some examples I'm mentioning here. There are a number of other techniques. So these electrical methods are nothing but we send some electrical current to the surface and which goes down, and based on that when we collect the potential difference from other area, and that will tell us that what kind of rocks are there below the surface, and that also will tell us that where the changes are there, the depth of the rocks are changing or thickness of rocks are changing. So that kind of series of informations will tell us that the structure below. And seismic method is something we use the seismic waves. These seismic waves, we know that it is the waves which are produced by the earthquake. And if there is no earthquake, then what will we do? We will generate an earthquake. We cannot generate an earthquake, rather we can generate a miniature form of earthquake. It's nothing but to make a small hole and to take a bomb. So use that bomb or a cracker or something which blast and creates and blast that. So that blasting creates a energy, and that will pass through, and we collect the signal from different areas, so that will tell us the structure below. Okay, so this all different methods will help us to identify the geological structure which are present below the surface, and this information will be really essential for a civil engineer to do its construction.